Hello and welcome back to module number 11. Today we're going to talk about chi-square tests. Plus, I'm going to start talking about graphics in R and what does it entail. And yes, the graphics in R entail statistical analysis, and so it's part of my aim is to show you what to do with it in order for you to produce more meaningful graphics in R using statistics. But beforehand, I want to talk about quiz number 3 and the result, and I want to make sure that we understand each other and what we are, why I'm so persistent on that subject. The issue is some of you answer correctly, but they did not. Example, in question number 2, they did not calculate the error minus a plus. So as a result, they did not have the right answer. So again, if you want to debate the result of quiz number 3, please do that with using open source R as your platform, so you will have a better understanding what is it entail. So the idea here is, again, I want you to show me what is the argument that you are putting forward in order for you to debate the result. It's not only, hey, I did 0.01 and you took 2 points out of it. No, it's not the issue of the 0.001 or 002. The issue is that did you use the R to calculate your conclusions, and is it based on your answer? The issue that was very transparent to me was in question number 2 and 3, where you did not, majority of you that answered this question did not calculate the error to the left and error to the right, and as a result you selected an answer that basically looked the same as what you got without adding the error. So again, I will post everything very straightforward on Monday morning. I will post everything, I will provide an explanation, but I want you to again ask question. Your job is to ask question. My job is to answer question. I might not answer questions as you expected, or I might not answer the question in a format that you are accustomed to, but this is the way for us to teach you. It's not one way or the I way, but there is different level of comprehension, and I'm trying to accommodate everyone. So again, ask questions, raise your concern, and I will be able to communicate and try to explain to you what is it entail. This is what my philosophy in teaching. Okay, so as I said, we need to move forward because the semester is almost over, and in this time we are going to talk about chi-square test, and I'm going to talk about graphics in R because, again, if someone will argue, why are we teaching graphics? It's not a graphic class. Yes, but in R is based on statistical analysis that you need to entail. So you will see the implementation of statistical analysis using a package called ggplot2 in order for you to generate the graphics, in order for you to communicate your results. Okay, so in this model, you will learn how and when to use the chi-square test for tables, contingency tables, and apply it to R. That's the objective, very straightforward objective that I want you to make sure. The idea of tables or contingency tables is very useful when we are trying to compare multiple population proportions. So it is used to simplify simple observation according to 2 or more characteristics. So it is also called, in statistics, it's called cross classification table. And the idea here is that if we will see gender, domain hand, left or right, gender, male or female, we have 2 categories with each variable, so it's called 2 by 2. Suppose we sample an example of 300 children. So we are having hand preferences and gender, female or male. And so we have some result that we can able to summarize it and be able to do that. To address the differences between those two proportions, we are using x squared test, and we are learning how to apply that. And so what we have done is we are applying the hypothesis testing, where the null hypothesis is the proportion of females who are left-handed is equal to the proportion of the male who are left-handed, and the alternative hypothesis is the two proportions are not the same. Hand preference is not independent of gender. And so look how I manipulate the idea of the hypothesis testing in order for me to actually test and apply the chi-square in order for me to answer the question. So this is the idea, and I want you to see where it goes. And so the idea here is that chi-square, it has to start with x square statistics, which is equal to all the cells, and we divide it in order for us to provide the answer. So the idea here is that we are going to apply the two cases has a 1 degree of freedom, which assume that each cell in the table has an expected frequency of at least 5. And this is again, assumptions that we probably will need to address. So the decision rule here is that if the x squared test statistic probably follows the chi-square distribution with 1 degree of freedom, we will probably have this idea of not rejecting the null hypothesis, rejecting the null hypothesis, and where does it falls into this decision rule or decision application that we need to apply to. So we are comparing the average proportion. So the average proportion is the p hat is equal x1 and x2 and divided by n1 and n2, and which is equal to x divided by n. So the idea here is that 120 females, 12 were left-handed, so it's 180 males where 24 were left-handed. So we add those together and we are getting, as a result, we are getting that is 0.12 is that based on all 180 children, proportion of left-handed is 0.12 or 12%. Okay. Since now I hope that everyone understands what we are doing and have a clear understanding. So finding the expected frequency is the trigger that will be something that I want you to focus, because this is where things are getting a little bit more complex. So to obtain the frequency for the left-handed females, we are multiplying the average proportion left-handed by the total number of female. And so the same thing that we are going to do with a male. So in this case, the female, the number, because the number is smaller than the male, is 0.12 multiplied by 120, which will be equal to 14.4, in comparison to the male, which is 180, and we are multiplying it to 0.12, and which is equal to 21.6. So what are we getting out of this table? We have observation, we have expected value or expected mean, and we can do that from the left and the right with regard to male and female. And this is quite interesting because, again, think about that. in the case of a data set or anything that you can count and have expected value out of it, which is quite useful. So the idea here is that we are performing the chi-square test where we add everything together in order for us to get a result, as you see below, 0.7576, which is the score of the t-test, the chi-test. So the decision in this case is that where is it all come down to? So the test is x square statistics, which is equal to 0.775, and the x square in the order of 0.05 with 1, the degree of freedom is 3.84. So the decision rule is that if it is smaller than 3.841, we reject the null hypothesis. If it otherwise, we do not reject the null hypothesis. So how do we do that? Again, this is way for us to do that, where the significant evidence that the two proportions are different is the 0.05. I hope that will make sense to you. You will have some exercise on it, so you will have pure transparency with that regard. In the issue of the x square test for the difference among more than two proportion, we can expand for more than two independent population, and we will not do all the we will not apply that are equal in that case, because we have multiple independent population. So where is it all come down to? It comes down to the chi-square test. And this is where everything has to be clear, and I hope it will make sense to you. So what do we have here? We have the x square for the two cases, 2 minus 1 and c minus 1, where it is equal c minus 1, which is the degree of freedom. I hope by now you know what is the degree of freedom. And the assumption here is that each cell in the table are expected to have frequency of at least 1. And so computing the overall proportion, this is the formula that we use in order for us to do that. And again, the expected cell frequency for the C categories are calculated in the case of 2 multiplied by 2 case, and the decision rule is the same. And so we have to make the call with regard to the hypothesis testing in open source R. And of course I'm going to do that because I'm obsessed with that. So this is my joke. So again, when we are talking about functions in R, we are talking about R norm, D norm, Q norm, and P norm. And I hope by now that you are all familiar with that and you are all comfortable with doing so. So again, with regard to the F distribution, we learn how to apply that, we learn how to calculate that, and for the distribution you need to the degree of freedom, the DF1 and the DF2, to generate a random sample of 50. So in this case, how do we apply that into the R functionality, if you may call it, RF, and it's n equal to 50, the DF1 is equal 15, the DF2 is equal 20. So let's do an example. The study gives you the following information on the age distribution of library online user to report that they are between 18 to 34 years old. 51% are between the age of 35 and 64, and 40% are 65 years old or older, and the revised data will provide us the library habits. So age of library users, frequencies, and we suppose that the result of a random sample of 200 will give us the following example. So based on those samples, can we calculate one or more of the three ages, group ages that we have here, the 18 to 34, the 35 to 64, and 65 over. So again, I'm doing this example in a very simple manner. I'm not going to hold a large container of data. I'm going to hold a very straightforward container. In the assignment, you will have a simple example and a more advanced example. So age in this case is the container of age. The frequency is come together as a container of frequency, and the chi-square, this is how we add it. We are going to say age divided by age and frequency, and the person's squares test test data is the age and frequency, that x squared is equal 6, the df or the degree of freedom is 4, the p-value is 0.191. So R will give you a warning, but in this case it will not be appropriate to test the result what we have seen here. So in doing so, we are going to see that some of the times the R will produce you an error message, and this error message that you did not provide a full documentation to the chi-square. So I will provide a full documentation how to apply this in the assignment. You will do that and you will see what is it entail in order for you to do that. This is just a warm-up in order for you to understand what is the chi-square and what is it entail. So as I said, I want also to focus on graphics in this presentation. And so when it comes to producing graphics in R, there are three types or options to the average user. Basic graphics, which is very simple, lattice, and the ggplot2. Each one of them provide us basically different output. So in the idea of basic graphics, we are talking about a simple way for us to plot basic bar chart or pie chart or even scatter plot. In order for us to do that, this is the plot types, and this is where we can apply or direct the R to give us points, lines, both points and line, or do other things, histogram and other things. And again, this is what the R can do for us in case of multiple distribution. Points types, we have 25 different points that we are able to put into the arguments and fill it up with different colors, or which can be a standard colors to all. So this is the output of the points that the R provides us. We also have different lines or types of lines. Again, we have 6 types of lines, and we have width and size, and each of that can be controlled again in the argument that you put forward in your execution. Colors, we have in a default we have 1 to 8 colors, which is the basic. 1 is black, 8 is gray, and in between we can go overboard. We can use 659 names, colors upon what you have chosen, and you will need to define them. We also have a color schema. What is a color schema? That it will represent your graph, example, in a rainbow or in a heat map or any other type in order for you to display it. The issue of transparency or the alpha transparency is also important. Again, it's up to you to decide where and how you're going to do that. The gray palette is also different. The vector value is between 0 and 1. Instead of 0, return black. So again, you need to, if you are choosing a gray pattern in your design, be careful what you will come up with. And so again, this is a type of colors that you can apply. Building basic plot, again, this is a basic plot, and as you can see, we can add a title, we can add fonts and etc. But the answer that always in my mind, is it good enough? And the answer is always no. And so good thing that it's easy to customize it and add more graphics based on it. So the idea here is that we're going to learn about two packages that I want you to be aware or to be more comfortable to use when we are talking about visualization in R. The first one is the lattice package in R. It was created by Shankar in 1993, and the idea here is that it was able to us to produce add-ons or able us to apply something that we are not accustomed to see in Excel. Something that like this is a very interesting idea of how to apply that. So the step of using this package is, first of all, you need to install the package, and then the next stage is you're going to employ the plot, and in this case the X plot, and it's come from the package itself. Embedded in the package is a data set, and in this case it's lat smaller than lot, and the data set is called queries, and you are able to generate visualization out of it. But you can do a lot of things with that, and you can also use the print command that I'm sure that most of you are familiar when you're using it in any web developing languages or C++ language, when you are asking for print as a way for us to do that. So why do we use lattice, and why is it not famous as ggplot2? Is because it takes a longer time. So the idea here is, in the first argument that I put forward for you, I use a formula that consists of x small multiple connection with the z connection with the x multiplied by y, and so basically it's y1 plus y2 and the connection with the x. And so those are a common platform that we are going to talk about next time in our time series. We are going to start in the second part. We are going to talk about creating your own model, or creating your own model in statistics. And so in this case, we are using this example, and we are using the application, and this is the result out of it. And try it. You have nothing to lose, and I hope you will enjoy it. But one of the things that the package also uses is wireframe. Wireframe is the idea that we are able to apply three-dimensional space to the graphic itself, which is quite cool. So in this case, I'm using wireframe. I'm using a database called Calzodi, and the idea here is that I'm applying light into it. I'm using light source, and this is my light source, and it's contained of the container of 10, 0, and 10, and the aspect of it is, again, I'm putting it into dimension in order for me to apply that. So is that good enough? Yes, but it's not simple enough. So in the idea of ggplot2 is the person who basically created the RStudio, the application that you are using nowadays. I gave you his personal website, I gave you the ggplot website, I gave you his latest book on the R package, how to generate the R package. And if you are passionate about the R, this is the book that we are going to read next semester with regard to the introduction to R. And as anyone else in the R community, he has a GitHub where he puts all his stuff on GitHub in order for people to test it and to try it. This is something that you, in my next class, you will need to do in order for me to evaluate you, but also to be able to share or to learn from others how to apply the GitHub. So the structure in ggplot2 in compared to the two other platforms that I talked about, it has some functionality. It has the aesthetics, it has geometrics, it has the statistical aspect that this is where we come in. This is where the graphics has an elaboration relationship with the statistical analysis that we are doing. We have a scale that we are applying in the graph in order to fit the graph dimensions, and we have other dimensions in it. Coordinate system, that is the canvas of our visualization. We have facing, we have position, we have data, we have annotation, and we have other elements that are also as important as the graph itself with regard to the data set. So the plot convey information with regard to the aesthetics, and the aesthetics for Hadley consists where is the X position, where is the Y position, where is the size of the element, the shape of the elements, and the color of the elements. All of that are part of the aesthetics that I want you to think about when you do your analysis on chi-square. Think about all those components. Geometric shape in the package consists of points, lines, line segments, bar, and text, which are always important as it is. The scale in the grammar in the grammar of graphics that Hadley uses as his framework is the aesthetic aspect. So in this case, we can control the scale of the data that we are presenting, and we need to declare that. So again, some of the geometric have their own particular aspect. Example, points, lines, bar, and text. All of it has some aesthetic shape. And in this case, again, we are using a data set that called mtcars, and we are giving it aesthetics, and we are playing with mt and mpg, which is two variable inside the data set that we are dealing with, mtcars, and we are giving in dimensions. What do we want to see and how we are going to present that? And again, we are able to add some additional points to our dimensions in order for us to show that there is something going on here. And in this case, a straight line throughout the graph will show us what is the outliner in this data set, which is important, especially to us as statisticians. So the mapping, the data, and other arguments that comes in to do that. We also need to remember that it also has some legends inside. Example, the NA, the default, or any aspect that are mapping. And as you're going to learn in your project that you're going to bring into the final project, you're going to see that some of the values that you're going to run, example, has a default value, or they have none so ever value. You will need to learn how to apply that. And again, the ggplot2, apply that and show you what is the legend that are overwhelmed and where is it come from. And again, in this example, I'm using a data frame, and in this data frame, I'm using 1 to 10 in the X, 1 to 10 to the Y, and again, I am able to show what is the hidden patterns in the data in order for me to generate the visualization and what makes the ggplot so unique, because we are creating layer by layer in order for us to apply that. This is the beauty of R or RStudio and the power of ggplot2. And so I highly recommend that you will visit the ggplot2 to learn more and apply that. I will also illustrate, I will give you a lot of illustration, is that about a simple map, how to apply a simple map. And I will use in this map a package called Shapes2 in order for me to create this map. And again, this is the code that I'm going to use, and this is the result of it. And again, we talked about visualization, which is again very important to me because I think it's very connected to statistics and statistic analysis. In this case, I'm using ggplot because what it allowed us to produce and what is it consist of. And as one of the foundation of the ggplot is the idea of a Wilkinson textbook. I don't have it with me in front of me, about visual grammar, and in this case he established these grammar rules into the package in order for us to do that. So this is it for the end of it. Everything will be posted. I will also post the correction way to apply the chi-square, and again, on Monday morning, you will receive from me the entire set of the quiz and able for you to ask questions. Please do not be shy. The whole point of this class is that you will ask questions. My job is to answer your question. Until next time, hope you have a nice weekend. See you next week.